Engine knocking, also called detonation, it is basically an abnormal combustion phenomena. So to understand abnormal, first you should know what's normal combustion. I have made a detailed video on it. You can see that, and here's a glimpse of it. That in normal combustion, it consists of various cycles, various strokes, upstroke and downstroke. So first of all, there's a downstroke, and the air and fuel are mixed together, and then there's an upstroke. So when the upstroke happens, it creates a high pressure and temperature condition, so the gas can be ignited and burned. And this they are burned by the burning of gas is basically a consequence of a spark plug, which ignites the whole, which basically a small flame which ignites the whole mixture. So the spark initiates a single flame front that smoothly travels across the combustion chamber and results in a second downstroke. The pressure rises gradually and uniformly during this single flame front, pushing the piston down. So this is normal combustion. But in knocking, what's happening is that before the action of the spark plug, there are various spots in the piston where the gases reaches their minimum threshold to ignite before the spark is ignited. So, or just after the spark is ignited. So the end result, the end consequence of any of the condition is that there's a non-uniform flames present in the piston. There's one flame front and various secondary explosions which occurs at various location in the piston due to the low threshold of the fuel at particular locations. So these auto-ignited spots in the piston creates something called pressure spikes. So the pressure in the whole piston does not remain constant. It's not due to only flame front. It's due to flame front and various secondary explosions, which is due to auto-ignition of the gases. So the pressure in the whole piston changes, and these pressure changes is result in sounds called knocking. So the effects of knocking are that obviously it's decreasing the power, it's decreasing the efficiency, and also causes piston damages because of various uneven pressure changes which occurs in the piston. So how can we prevent it? The main basic two reasons are: first, to use a high compression ratio, which I have discussed in my previous video, and the second obvious one, the most obvious one, is using a higher octane fuel. So lower the octane number, higher the resistance, lower the octane number, lower the resistance of knocking, because the threshold of that particular fuel to get ignited is low. So that's why we see more knocking in the diesel engine, which has a lower octane value compared to petrol, which has a higher octane value.